Hello there. Let's talk about hybrid programs. What's a hybrid program? A hybrid program is basically a program where you have multiple modules, many written in different languages, all compiled into one executable program. Why would you want to make a hybrid program? Well, maybe you have C++ as one of the modules that you're creating, and C++ is a high-level language, so it makes it easier to write big, robust programs with GUIs and like big fancy design patterns and things. But maybe at some point you want to interface with the C program, so it might make sense to, kind of jump into some C code. Maybe also you want to write a little module in assembly, because maybe one part of your code needs to be really, really fast and efficient in some way. And assembly gives you a little bit more control over how the code compiles down to machine code. Assembly is just, a level up from machine code. So let's see. I'm just going to write a quick program to demonstrate that you can do this and you can have these modules call each other. First off, I should probably draw a little bit about what I'm even talking about with multiple modules. So I'm going to do my little annotator here, and yeah, there we go. Basically, imagine that you have a C++ module, and we'll call it the driver. And I'll say like driver.cpp. Okay, I think I'm drawing this backwards. I'm going to draw this down here. Driver.cpp. Excuse my penmanship, I don't have a smoother setup on this thing. So we have driver.cpp, that's one source code. Maybe you have like another module, another source code module. I'm going to call it c.c, which is just some C code. The driver, usually the way I like to refer to it, and one of my favorite assembly books refers to it, is the driver is where the main function is, so that it's sort of like the entry point of your program. But then maybe we'll have another module that has some other kind of CPP code in there. I'm just going to call this file cpp.cpp. And maybe we have another module that's written in assembly. I'm going to call this hello.asm. Okay, so just several source code files. We will compile them each to an object file. Sometimes I think with new programmers, they think that you just compile a source code directly to the executable. We're not going to do that in this case. We're going to get a little bit fancier. Doing it this way, by the way, will increase your compiling efficiency when you start getting used to Makefiles. I don't know if you're already using those, but it's a good idea. So we'll write a script to compile, or a Makefile to compile, or some kind of a build system to compile. We'll compile the CPP driver to just a file called driver.o, O for object file. So O for object file depends on driver.cpp. We'll have another file called c.o, so the object file c.o depends on c.c, and so forth. So I'm just going to go cpp.o, circle it, and then down here we'll do hello.o. Notice how all of these modules, regardless of the language they are written in, compile down to an object file. That's really what it is. The higher level languages are just an illusion for us humans. So then at the very top, we want our actual executable file. We'll call it main, because that's kind of a standard thing sometimes. So it's like our main, we'll have a file named main that we can execute. And of course, inside it, somewhere is going to be the main function. Spoiler, it's going to be inside the driver. Remember, the main function, if you're using GCC libraries, has to appear in exactly one place, one module in your program. It should appear one time and one time alone, not zero or more than one. So the main executable depends on the driver object file, the C object file, and the C++ object file, and the assembly hello object file. Looks complicated at first until you stare at it a while, and then you just realize, oh, every source code is going to compile to its own object file. And then after we have all the object files, we're going to have our executable just sort of linked together at the final linking stage. So with that in mind, I'm just going to copy paste a Makefile that I already wrote. It's like my pre-solution, because this is not a Makefile video. And I just want you to know, just real fast, what it looks like. All I'm doing is I'm going to make some variables for my C++ compiler flags and my C compiler flags and my YASM assembler flags. I'm really not doing anything fancy. I'm just sort of setting up some variables so I don't have to type. The newer Ubuntu stuffs need a no executable stack flag and a no pi flag. So here we're just like making variables for linking. My executable's name is going to be main over here. I personally like to make files that default to a cute help menu. I know most people just default to building, but you know, for educational purposes, I think this is a little more fun, a little easier. So this way, later I can just type make menu or make build or make run or make clean or whatever I want to do. And I'm going to make a target called run, which is what we're going to be using, and then a target called build, which just only builds everything. The run target obviously depends on build, so that the program actually gets built before we try to run it. And if you don't know Makefiles at this point, it's okay. This is not a Makefile video. I'm going to make some Makefile videos in the future. Then my binary, the main program, is just going to depend on all these object files. Notice how it depends on the driver, the hello, the C++, and the C object files. So really, at the linking stage, we're just going to use G++ to just sort of link all the object files together. Then we have a little section to compile each source code file. So in order to make driver.o, I'm going to depend on the driver.cpp. And then when it comes to actually compiling it, I'm just going to type the commands to compile it here. Don't worry about these crazy variables. I'm going to make more videos in the future. And then each module gets compiled in its own way. Then I just have a little target at the bottom called clean, because I like to be able to just clean my build area of object files, because I don't know about you, but I like a clean build area. I'm a clean build area guy. I don't like a dirty build area. So that was the Makefile. Again, this is not a Makefile video, so don't worry too much about it right now. The next thing we should do is make a driver. Again, I'm going to copy paste from my solution here, because the driver should be easy. This video is mostly going to be for people who have never done assembly before, so I'm just going to assume you know a little bit about C++ and C already. So I'm going to say touch, let's see, driver.cpp, so that I can get the driver file in there, and I'm going to go nano driver, probably could have done that in the first place. Then I'm just going to paste my solution. Oops, you can tell I copy pasted this from my IDE because I have the extra tabs in there, which I love. One thing to keep in mind is that I guess like one of the first rules that I want to tell you for hybrid programs is that assembly doesn't understand something called name mangling. So what is name mangling? Name mangling is basically when you have a, oh, this is not going to get called. So this is maybe not a great idea to show you name mangling. Let me start on one of the other ones real fast too. Let's do the C++ module. Okay, so I'm going to go nano cpp.cpp. I know it's a silly name. I know it. So cpp.cpp, this is just a simple C++ program which is meant to be called by the assembly module, just to show you that we can. And so we just have a little function here, void, you know, the cpp function. So it's just a function that doesn't really return anything. Inside of it, I'm just going to print hello, this is the C++ function, no problem. Notice at the top, this is the first important thing that you should understand. In C++, we have overloads, right? You can have the same function name, but with different argument lists. And so that gets resolved under the hood by the name actually kind of changing based on what the argument signature is, what the prototype signature is. So that's great and all, but in assembly, at least at this level, there's no way to really differentiate between overloads. In assembly, we'll just call a name of some function. But if we try to call a name, let's say of just the cpp function, if we say call the cpp function in assembly, it's not going to work because the actual function has not been compiled to have that name. It's been compiled to have the cpp function and a bunch of extra symbols indicating what the argument list is. This is great for C++ programs, but it's poor, it's bad for other modules to be able to call the C++ function because they won't really know what the actual name is after the mangling has been done. So what you want to do is make a little block called extern C, just like this. You say extern and then C in quotes, and then do a scope with braces. And inside of that, just put the prototypes of any function that you want to be available to other modules. So for example, we want the cpp function to be available to assembly modules and C modules, not just other C++ modules. So I'm just going to put the prototype of it right there. You can put as many prototypes as you want. I think they should come from the same source file. So basically every different source file where you want something to be available elsewhere, you would put an extern C block for its prototype. This disables name mangling, which means the compiled name of the CPP function will actually be the CPP function. So it's pretty good. This will make it available to assembly. So now that I've kind of explained that, I can maybe close this and go back to what I was doing before. So this is the main driver program. We don't need to engage in, we don't need to disable name mangling for the main function, because no one is going to call main except the GCC libraries or like the OS. But when the C++ module calls other modules, it needs to be able to call the right name. And remember, in C++, there's name mangling enabled by default. So if I tell it, let's say on this line right here, or you can do Alt-N to get line numbers on Nano. Let's say line 16, we want to call on the hello module. Well, C++ by default will assume that hello has name mangling applied to it, which means it will actually try to call some name that is totally different based on the prototype signature, the incoming arguments and things like that. But so we want to disable that because we want it to just call the actual name, because hello is going to be a function that we make inside of assembly, so it's not going to be name mangled. So that's why up here on line 7, we enter its signature. Oh, actually, this is from a different version of something that I was doing. I'm not going to return anything from hello. We'll do name demangling with our extern C block, just void hello. And now when we call hello, it's actually going to call a function called hello without any other mangling. Same thing for the C, SEA. Oh, that was from a different version I wrote. We're not going to be calling C in this module. Don't worry. We're going to keep it simple. So pretty much we're going to print hello, and then we're going to print, then we're going to call the hello, and then we're going to say goodbye, and then that's going to be the end of the program. So let me close out of that and just double check what I have written right now. So we've got CPP and, okay, we need to do C, nano C.C. Okay, so let me get my solution real fast here. It's a simple program. Literally, it's just a C program that prints something. Remember in C++, we've got the IO stream, but we don't have that in C. So I'm just going to use printf. Oh, by the way, this is a C function, hi. So done with that. Pretty easy. Shoot, you know what? I need to start learning how to do clear and LSA, so I can just go up, up, up. So C++, C, and the driver, and the Makefile, which is huge. I just realized that. And now I guess we can start writing our hello function. Okay. So maybe I want to write this in the Genie program. So I'm going to, well, maybe I'll say touch, and I'll say hello.assembly. And then now that it's there, I can try to open it up. Let's see. Hello.assembly. Okay, so now let's write an assembly program. I'm not going to spend too much time talking about this, but I'll say like data section here, and we'll say section.data, and then we'll say system calls. This is not a system calls video. I'm just going to do this very quickly without explaining. System write is going to be code 1, I guess. And then we're going to do file descriptors, 1 for std out. Whoops, std out. It's going to be equal to 1. This is not a file descriptors video. I'll put FDs, I guess. And then we'll make some C strings. C strings, just character arrays, basically. I'll say, well, you know what? I don't want to type this all out, because this is not a lesson on variables. I'm just going to copy paste my existing solution here. And, long story short, I'm going to try to make this a pretty program that prints hello and goodbye and things. And so we just have like some variables that sort of just, hold strings and hold the string's length. And we're going to do one that calls a new line and so forth. Actually, that'll be a different video, but I'll leave it in there for now. So now let's make the text section. Remember, the text section in YASM is just for the actual code of your program. So I'm going to go section.text. And then we need to set up some external symbols. So right now, at least for the purposes of this source code, this source code is inside of the hello module. So you can imagine we're inside of hello.o. All the O's get linked together in the executable, but between themselves, there's kind of a little bit of like a border situation happening. There's like some separation. So Not all symbols that I put into hello are going to be available to the other modules, even if they're part of the same executable. It's kind of convenient because you would like sometimes to be able to write tons and tons of functions that are only available inside of your assembly module, and they might not be available to other modules, and therefore you don't want to pollute the namespace, I guess, of the global namespace of the executable. So by default, if I make a function called hello, how you make a function, just, quick recap here. This is not a functions video. You just make a symbol with the name of the function you want, and then you just put a ret after it, and then you hope that whoever got you there is going to use the call instruction. But anyway, for now, we're just going to say this is our hello function. Okay, I cannot call the hello function now from another module. I have to make it visible to the other modules with a special keyword called global. So I'll say global hello, and now after we compile and link our program, the hello function will be available to the other modules, but not anything else that I type without marking it as global. So let's go ahead and let's do a welcome message. And this is not a system call video. Maybe I should just copy paste this instead of just looking at it. This is a welcome message here. So I'm going to say first, I'm just going to quickly, breeze through what we're doing in case you're interested, but you don't have to care too much about this right now. We're going to tell RAX what system call we want to make. The code for that is what I put up in system write, which is just code 1, means let's write to a file. We'll give it the file handle. That's going to be the variable we made called fd_std_out, which means we're going to be giving it the file handle of 1, which means we're telling the system call to print to standard output, because file handle 1 is always standard output. And then we just give it the a pointer to the first character of the message string that we made, and then tell it how long that message is. Then we do system call. This should actually this should actually print a string. Okay, so then let's see, down here I'm going to make a function called crlf, because I'm lazy and I don't like constantly adding extra stuff to the string so that there will be like a new line feed situation. So I usually like to make a little function somewhere called crlf, carriage return line feed is what it stands for. And it's the same thing. It's just like load up the system call registers so that it knows I want to print the string, which is just a line feed, carriage return line feed, and then actually call system call and then return to the caller. So this is just a really, really simple function. And if you look back up here, let's see, crlf, I guess I am going to be doing it. It's just a string with the /r/n, or the carriage return line feed characters. In ASCII, those are 13,10, so I can put that there instead of a literal quoted string. Okay, so we got that, and then that means after the welcome message, I can just like call crlf in order to have the cursor jump down to the next level after that string is. Notice how I don't have any line feeds after my strings. That's kind of why I like to do crlf. And it lets me just call crlf a bunch of times if I want to just like space things out temporarily. Okay. So we've got the hello function. And now we're going to print another message here. I'll just explain this real fast. So I'm going to print a message about calling a C program. So same thing, we're just going to tell the system call service that we want to print a string, and it's going to be our string here that says, we're about to print what do we say? We're about to call the C function, and then later we're going to call the C++ function. So we're just going to print a message announcing and do crlf. So that's really nothing new at all. And then down here, we actually call the C function, which is not going to be in this module. It's going to be in the C module, the other source code. So that means somewhere in this program, we need to let our assembly module know that the C function is available, because it kind of goes both ways. In assembly, I have to mark a function as global if I want other modules to be able to call that function. But I also have to mark a function as external if I want to be able to call some other module's function. So we have to go back up to the top. I mean, somewhere in the text section I think would be fine, but for me, I just like to put it at the top. So I'll say externals, and then I'll go extern keyword, and then just name the function that I intend to call. This way, when the linker is trying to link all the objects together, it doesn't get upset because you tried to call a C function which is not in the current module, it'll understand that it's going to happen, it's going to call other modules for that. It usually gets upset right away. And then while we're at it, let's do extern the cpp function, because that's going to come from the C++ module. So now we have both of our external functions set up. We've marked our global hello function so other modules can call us. And then, let's see, what did I do wrong? I put the C message in the wrong spot. I was inside of the crlf function, so I'm just going to copy paste that back up here. Okay. So then we'll do the same thing for the C++ message, or for the C++ stuff. I will first print a C++ message with these lines up here. That's just like a regular system call, and then I'll do a crlf, so nothing new, just printing something. And then I will actually call the C++ function, called the cpp function. Then I'll say goodbye with another block of text. Again, not super important or complicated, so I'm just going to paste it. Just another string. And then when we're done, I'll just say, return. We're done. So that means, if you notice how we don't have like any symbols in here called _start, that means this is not a pure assembly program. And we don't even have a symbol inside of here that is called main. So that means this hello.asm module is not going to be the entry point of our program. It's just going to expose a function called hello, which does some stuff. The entry point of our program is really, let's see, where is that? Oh gosh, okay. I think I already closed it for some reason. It's the driver program, which we talked about. So remember the driver program, it's got a main here. So that means this is going to be what the GCC libraries or the operating system calls, however you want to think of it. So this is the entry point of our program. It'll just print something quickly. Then it'll call the hello function, which means execution will jump in to the hello module. So at this point, we know how to call an assembly module from a C++ module. And also, it would be really easy to apply this logic to have a C module call on an assembly module. And in fact, you can use this logic to have every type of module call on any other. I mean, just if you have a C++ function, either being defined in the current module or being referenced in another module, just make sure that you have an extern C block. And then if you're inside of a C++ module and you're going to call a non-name mangled module like C or assembly, then just do this block here. No problem. What else can I really tell you? The C module, we looked at that. The C++, we looked at that. Pretty easy. Hello module. I mean, I guess we're kind of done already. So what we should see now is a little intro here. Hello, my name is whatever. And then when we jump into the hello module, we should see a little welcome message about being in the assembly module. And then we should see a message about calling the C function. And then the C function should print, let me open that up for you. Let's see, the C function should print, oh, by the way, this is the C function. And then when it returns at the very end, remember, even in a void function, there is a return statement implicit at the end of scope. So when it returns, it'll come back down here, and then the C++ message will get printed, and then the C++ function will get called, which is going to end up being it just prints, another message. This is the C++ function. Then when it returns implicitly at the end of the function, then we get down to here where we just basically say goodbye and then return to the caller. The caller in this case is going to be the driver program, because this whole time we were just inside the hello module, or inside the hello function that we called. So then the driver will say goodbye, and then it will return control to the GCC libraries or the operating system, ending the program. Let's see if that works. Okay, clear. And so, the way I write my make files, I like to do a little menu. I type make, and it's like, oh, the menu. Make menu. Make build. Just in case, just to see what's up. Okay, clear. And then I'll do make one more time. So I really just want to say, let's do clear and make run, because that's really what we're after. Again, run will implicitly call build. So do that, and it seems to have succeeded. It wasn't actually very exciting. Let me do a make clean so you can see it compile real fast. We run it, it's compiling. That was still kind of fast. So up here is basically the Makefile, all these lines. They're just calling your normal compiler and assembler tools and linker tools. And then here's the driver, like we said, it prints the hello message, my name is whatever. I love that name. I have a strange name generator that I found online. That's not my name. You can call me that if you want to. And then we have the message that we're going to call the hello module. So now we've called into the hello function inside of the assembly module. Assembly module prints, hello, I'm inside of here now. And then the assembly module says, now we're going to call the C function. And then the C function actually executes, and it is now printing with its printf function call that it did. By the way, this is a C function, hi. And then it returns to the caller. Maybe I could have added another print statement if I felt like I wanted to spend more time. But it returns to the caller, which is the hello function. Then we get to the next part of the hello function where it's like now calling the C function as a print statement. Then it actually does call the C function. The C function prints itself out. Hello, this is the C function. And then the assembly module says goodbye. It says it's finished. And then it returns to the caller. So finally, at the end of this print statement, there's like that little return statement at the bottom of the hello module that returns to the caller, which was the driver.cpp program. So then the driver prints, the driver is now back in control. You can see that message behind the terminal here. The driver is now back in control. Then it says goodbye. Then it returns 0 to the operating system, and the whole program is done. So it's important to understand that if you want to pass arguments, right now I'm just going to say, I'm going to make another video that is more robust in the future about passing arguments back and forth between these. It's important to understand for now that you can pass arguments between all these different module functions if you want. Like if I wanted to give the hello function an incoming argument, let's say like an integer or a character value or a pointer or something like that, I could just load up appropriate registers. Remember, we have argument registers in assembly. I can never remember if RSI or RDI are the first one. I think I'm going to say RDI is the first argument, just off the top of my head. I always look that up. So if I wanted to call, let's say, give an integer argument to hello when I originally called it, then from the driver, I literally would just have to type an integer argument in there, and then under the hood, the RDI register, assuming that I'm right about RDI being the first argument, the RDI register would get loaded up with that value. And so from within your assembly program, all you'd have to do is do something with the RDI register, load it up, save it, do whatever it is that you think you're going to do. So that's how you pass an integer or like a character or a pointer from C++ to assembly. It works the same exact way if you want to pass arguments when calling from C to assembly. If you want to pass integers from assembly to C or C++, it's the same thing, just backwards. First, you load up RDI as the first argument register with whatever value you want to pass to C or C++. And then in the signature of the C++ function, you just expect, a long or, whatever you were going to get. And the register will already be loaded up. Remember, the C++, it's not really happening on the machine. It gets compiled down to assembly. So this source code that we're looking at, it's another illusion for our benefit. It's not happening. It's getting assembled and then compiled down to machine code. And then that is what's actually happening on the machine. So when you write that you have an argument in a C++ function signature prototype, you're not really writing that at all. You're just saying that the A variable should get loaded from whatever the RDI register had. Or if you previously loaded the RDI register and you want to call a C++ function, that's what it would expect, the RDI register. So it can work pretty seamlessly, just calling things back and forth. So yeah, I guess that's all I really had to say. This is the basics of writing a hybrid program. Thank you for watching. I hope you learned a little bit of stuff and had a little bit of fun. See you in the next video. Hey everybody, thanks for watching this video again. From the bottom of my heart, I really appreciate it. I do hope you did learn something and have some fun. If you could do me a small little favor, could you please subscribe and follow this channel or these videos or whatever it is you do on the current social media website that you're looking at right now. It would really mean the world to me, and it'll help make more videos and grow this community. So we'll be able to do more videos, longer videos, better videos. or just I'll be able to keep making videos in general. So please do me a kindness and subscribe. You know, sometimes I'm sleeping in the middle of the night and I just wake up because I know somebody subscribed or followed. It just wakes me up and I get filled with joy. That's exactly what happens every single time. So you could do it as a nice favor to me, or you could troll me if you want to just wake me up in the middle of the night. Just subscribe, and then I'll just wake up. I promise that's what will happen. Also, if you look at the middle of the screen right now, you should see a QR code which you can scan in order to go to the website, which I think is also named somewhere at the bottom of this video. And it'll take you to my main website where you can just kind of like see all the videos I published and the services and tutorials and things that I offer and all that good stuff. And if you have a suggestion for clarifications or errata or just future videos that you want to see, please leave a comment. Or if you just want to say, hey, what's up? What's going on? You know, just send me a comment. Whatever. I also wake up for those in the middle of the night. I wake up in a cold sweat and I'm like, it would really mean the world to me. I would really appreciate it. So again, thank you so much for watching this video, and enjoy the cool music as I fade into the darkness which is coming for us all.